Student, today we will learn the chapter Geometric Progression. Student, before going this chapter, you should be learn what is the sequence and series and arithmetic progression. In the previous video, okay, then you should be go to the geometric progression. Now, I am telling you what is the geometric progression. Now, look here, 2, 4, 8, 16, 32. Can you tell me what is the new term? Okay, can you tell me? What is the new term? Okay, let the new term will be, here we can see twice here, twice here, twice here. So twice of this, that is new term will be 64, and the new term is here 128. Now we can see the ratio of these terms are constant. This is a GP, geometric progression. Okay, what is the rules here? The next term is related with the previous data with a particular ratio, then it is geometric progression. Okay, so now we can write here T1, T2, T3, T4 and Tn in a GP if ratio are for ratio of the next data with the previous data. Okay student, T4 upon T3, T5 upon T4 and so on is constant. So if this ratio is constant, then it is in GP. Okay student. Now you can see let T1 equal to A. So you can see T2 equal to T1R. T2 equal to from here T1R. So it is A into R. T1 is A. Now you can see T3 equal to T2 into R. T3 equal to T2 into R. So we can write T3 into R, T3, T2 into R. T2 is AR into R. So we can here AR square. In the exponent, this power is adding. You know the exponent. If you don't know the exponent, you should be learn the chapter exponent. Okay, if you don't know the topic of an exponent, you should know the topic exponent, AR square. So not we can say T4 equal to T3 into R. Now T4 equal to T3 into R. So T3 was AR square into R. We can say AR cube. So similarly, we can say if 4 is here is 3. So what about if 10 is here it should be 9. So we can say Tn term should be AR n minus 1. From starting, if we want to find nth term, now we can use the formula AR n minus 1. Okay student. Now you can see 2, 4, 6, 8, 10. And if we 10 divide 2, 4, 8, 16, 32. Now it is L. Then how we can find this term? L divided by 2 means 32 divided by 2 equal to 16. Now how you can find 16 upon 8? So 16 upon divided by 2. So we can find 8. It means if we dividing R, then we can find the third term from last. So we can use this formula AR square dash 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 dash. That Tnth term is L. So T1 from last, that is L. T2 from last, that is L upon R. T3 from last, that is L upon R. Again dividing by R, so we get L upon R square. Similarly, Tn from last, that is L upon, you can see here 3, here is r square, means n r to the power n minus 1. Okay student, so we can say we are learning first formula, that is Tn from starting, that is arn minus 1, Tn from last, that is L upon Rn minus 1. Okay, and Tn we can say as last term L. Okay student, so with these two formula we have learned the GP, Tn from starting, that is Arn minus 1, Tn from last, that is L upon Rn minus 1, where L may be nth last term, that is Tnth term. Okay student. Okay, these two terms you have to learn. Now student, I am asking you questions. Find third term from start and from last in GP 3, 6, 12, 24, 48. Okay, so we can see here Tn equal to Arn minus 1 from starting. Okay, so here L equal to 48, R equal to 6 upon 3 equal to 2, and A equal to 3. So we can say T3 equal to AR 3 minus 1, value of A is 3, R is 2, and here is 2. 3 into 4 equal to 12. Now you can count here. First, second, third term is 12. Understand? Now third term from last, first, second, third, that is also 12. Now how we get it? T3 from last, that is L upon R to the power n minus 1, and here L is 48, R is 2, 3 minus 1, 48 upon 2 square equal to 48 upon 4, we are getting 12. So we can see here first term, second term, third term is also 12 from last, isn't it? So student, we go through this example, we can understand these two formula. Right student? So now we are going to find out the sum of n term in GP. What is the next topic? Sum of n term in GP. S equal to A plus AR plus AR square dash 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 plus L, where L equal to nth term and AR n minus 1. Okay, now if we multiplied by R, we are multiplied and writing here AR, and multiplied by R, we are writing here AR square. So we can say at the last we multiplied this and we are getting here LR. Equation 1, equation 2. L equal to Tn equal to AR n minus 1. Now if we subtract this, okay, subtract this, what we get here? Now you can see these are the same term, this will be cancelled, now this will be cancelled and this will be cancelled. what we left here? S 1 minus R, and here is A, and here is minus LR. Okay, so we are getting here minus LR, so we are writing here LR. So now we can write here S equal to A minus LR upon 1 minus R. This is the sum of n term if R is less than 1. If R is greater than 1, we should use LR minus A upon R minus 1. So R minus 1 will be positive. So we can use if R is greater than 1 this way. Okay, student. Now, student, we put the value of L here. This, so what we get the formula? S equal to A minus LR upon 1 minus R. Putting the value of L, A R n minus 1 into R upon 1 minus R. What we get taking A common, 1 minus R to the power n upon 1 minus R. So we can use this formula also. Now this formula will be for R less than 1. Okay. Now if we put this formula for R greater than 1, R less than 1, R greater than 1, for R greater than 1, what we can find here? A R to the power n minus 1 upon R minus 1. Okay, student. Sum of n term we can find using this formula. Now, student, in GP, sum of infinite term, let S equal to A plus AR plus AR square plus AR cube up to infinite. Again we are finding multiplied by R. We write here AR plus here AR square plus AR cube and so on. Now subtracting it, what we get here? We get here 1 minus R. A, this one is A, and this all are cancel out. So what is here? So S infinite, sum of infinite, that is A1 minus R. And this formula will be used only for if R less than 1. Okay. Now this formula we can find using this also, A minus 1 minus R to the power n upon 1 minus R. Now you can see if R equal to 0.1, then what is the value of R square? 0.1 square, 0.01. What is the value of R cube? 0.1 cube, that is 0.001. You can see here, if n tends towards infinite, what is the value of R to the power n? Then it tends towards 0, 0.001, 0.0000 and so on. So we can say if R is less than 1, hence R to the power n tends towards 0. Okay, and n tends towards infinite. So we can say S infinite is A1 minus 0 upon 1 minus R. So we can write formula A upon 1 minus R. This is the same formula as I have already explained in previous board. Okay, now let one question is, if S equal to 2 plus 4 plus 8 plus 16 plus dash dash dash, find S8. So S8 equal to A R to the power n minus upon R minus 1. Since here R equal to 4 upon 2 equal to 2 equal to 8 upon 4 equal to 2, it is GP. Okay, so we can use here 2, R is 2, and we have to find 8 term minus 2 minus 1, 2 upon 1, and we can solve this. 256 minus 1, 2 into 255. So it is 510. Okay, student. Now the question is 1 plus 1 by 2 plus 1 by 2 square 1 by 2 cube. Find as infinity. Since 1 by 2 upon 1 equal to 1 by 2, 1 by 2 square upon 1 by 2 equal to 1 by 2 less than 1, it is R ratio, hence it is GP. So S infinite is A upon 1 minus R, 1 upon 1 minus 1 by 2, 1 upon 1 by 2 equal to 2. Okay, answer, student. So this way you can find sum of infinite term. Right, student? Since here we are using the formula R is less than 1. Okay, student. So after understanding this topic, sum of n term and finite term of AP, now we can see here in GP T1, T2, T3, T4, we can see R equal to T2 upon T1 equal to T3 upon T2. So we can write T2 equal to T1 T3 and T2 equal to under root T1 T3. Similarly, if we use this formula, so T3 equal to under root T2 T4. We can write here also. Okay. So we can see the middle term is taken by this way. Now we can say this way: one geometric mean of A and B, and that is under root AB. Okay. Now the question is, find one geometric mean of 2 and 4. Answer is geometric mean equal to under root AB, that we can write 2 into 4 equal to 8 equal to 2 root 2. Answer. Okay. One geometric mean of A and B. So similarly, to find n geometric mean of A and B, we can write A, G1, G2, G3, Gn, B in GP. Here G1, G2, G3, Gn are geometric mean of A and B, n geometric mean of A and B. So writing here we can see B is number of n plus 2th term. So we can write n plus 2th term A are n plus 2 minus 1. First term is A. So using this we can find the value of R. Okay, this way first we find the value of R. After that we can find T2 equal to first geometric mean, that is AR, and T3 equal to second geometric mean, that is AR square, and so on, n geometric mean. N plus 1th term A will be nth geometric mean, that is ARN. Okay, so using this formula we can find nth geometric mean. Now take a question. Find 2 geometric mean of 3 and 6. So solution is nth geometric mean is ARn, where R is equal to B upon A to the power, we got n plus 1. We can see this formula here. R is equal to B upon A 1 upon n plus 1. Okay, student. So you can use this formula directly. So we can write here R equal to 6 upon 3 to the power, that is 2 geometric mean between 3 and 6. So we can write here 1 upon 3 plus 1. So we can 2 the power 1 upon 4. Okay, student. So first geometric mean is 3 into 2 the power 1 upon 4 to the power 1. Right? 3 into 2 the power 1 upon 4. And second geometric mean is 3 into 2 the power 1 upon 4 to the power 2. So that is 3 into 2 the power 1 by 2. Okay, student. So this way you can find the n geometric mean. Now student, you can see here 2, 4, 8, 16. If you add any term, any value, letter 3 in each term, what you get? 5, 7, 11, 19. It is not in GP. Okay. Similarly, on adding and subtracting in each term, it is not in GP. As we have seen in adding, as we can see in subtracting. Okay, student. So student, now let 2, 4, 8, 16 now multiply by 2 in each term. What we get? 4, 8, 16, 32. It is GP, isn't it? Here ratio is 2, here is ratio is also 2. Ratio is no change. Okay. Similarly, if divide by 2, what we get? 1, 2, 4, 8. It is also GP and ratio is not change. So we can say there is a formula. If we only multiply and divide in GP by constant term in each term, then it will be in GP and common ratio will be no change. Now you can see, let GP AR square AR cube dash dash dash, ratio is R. Now multiply by K in each term. What we get? KA, KAR square, KAR cube. Now T2 upon T1 equal to KAR upon A equal to, we can see here, we can see here it is equal to R, and T3 upon T2 is also KR square upon KAR, we can see R. Ratio is R, no change, and GP. Okay. Similarly, if we divide by K, what we get? A upon K, AR upon K, AR square upon K, AR cube upon K. What we can see here? T2 upon T1 equal to AR upon K upon A upon K equal to R. T3 upon T2 equal to AR square upon K upon AR upon K. We get our ratio is R, no change, and it is GP, and it is in GP. So student, we concluding that if we multiplied and dividing by K in each term of GP, then it will be GP and common ratio will be no change. Okay student, so after understanding these basic formulas of GP, we rest this video here, and in the next video we will solve so many questions of this formula what we have learned today in GP. Okay student, so thank you for watching.